So here in this question we have two rational functions that are added to each other. We have to find its limiting value when x approaches the value 1. So let us begin by first substituting the value of x with 1. So we have 1 minus 1 squared, which is 1, plus 1 divided by 1 minus 1. So that gives us 2 over 0 plus 1 over 0. So 2 over 0 is infinity, plus 1 over 0 is infinity. So infinity added to infinity, so this does not make any sense here. So what we are going to do, we are going to add the two rational fractions so that at least it is in the indeterminate form. And after that we are going to factor out the common term, and then we're going to find the final limiting value. So let us begin by first adding the two rational functions. So here we have limit x going to 1. So the first rational function, so we have 1 minus x squared in the denominator. So we can write 1 as 1 squared minus, so that it becomes 1 squared minus x squared. And we will apply the identity that a squared minus b squared is equals to a minus b times a plus b. So we have in the denominator 1 minus x plus 1 plus x. Now what we're going to do, we have x minus 1 in the denominator of the second rational function. So what we're going to do, we are going to take negative 1 as the common factor. Then we'll have 1 minus x. We'll have negative 1 multiplied to 1 minus x. So this gives us limit x goes to 1. We have 2 divided by 1 minus x times 1 plus x minus, so this plus multiplied to this negative 1 is going to give us a minus 1 over 1 minus x. So we perform the subtraction of the two rational fraction, so that will give us 1 minus x times 1 plus x in the denominator. So we have 2 minus, so we have 1 minus x, so that means it will be 1 plus x in the numerator. So let's do the calculation. So that should give us the limiting value of x going to 2, x approaching 1. We have 2 minus 1 minus x divided by 1 minus x times 1 plus x. So 2 minus x, so we have 2 minus 1 in the numerator, so that will give us 1 minus x divided by 1 minus x times 1 plus x. Now before going further, now if we do a direct substitution here by replacing x with 1, so that gives us 1 minus 1 divided by 1 minus 1 times 1 plus 1, which will be of the form 0 divided by, so 1 minus 1 will be 0, 0 times 2 is also going to give us 0. So now that we have in an indeterminate form, so we'll say that x minus 1, or we can say 1 minus x is the common factor. Is the common factor in both numerator and the denominator, which we can get rid of, so that our rational function now gets converted to 1 over 1 plus x. Now we do the substitution. So we have 1 over 1 plus 1, which gives us half. So this is going to be the limiting value of the given rational function. So we have two rational functions. We have 1 over x squared plus x minus 2 minus x of x cubed minus 1. We have to find its limiting value when x approaches 1. So let us begin by first doing a direct substitution. We are going to substitute the value of x with 1. So that leaves us with 1 plus 1 minus 2 in the denominator minus 1 over 1 minus 1, So we have 1 over 0 minus 1 over 0. So 1 over 0 is infinity minus infinity. So this is an indeterminate form. However, we need something of the form 0 over 0 in order to continue. So what we'll do, we'll subtract the second rational function from the first one by taking the LCM. So let us begin. So we have limit. So before doing that, what I'm going to do is I'm going to factorize x squared plus x minus 2. So x squared plus x minus 2 upon factorization by splitting the middle term will be x squared plus 2x minus x minus 2, which is equals to x times x plus 2. So we have taken x as the common factor from the first term and the second term, and then we are going to take negative 1 as the common factor from the third and the fourth term. That leaves us with x plus 2, which gives us finally x minus 1 times x plus 2. So this is going to be the factorization of x squared plus x minus 2. Then we have x cubed minus 1 in the denominator of the second rational function. So that can be rewritten as x cubed minus 1 cubed. So here what we are going to do, we are going to use the identity a cubed minus b cubed is simply equals to a minus b times a squared plus ab plus b squared. So we have x minus 1 multiplied to x squared plus x plus 1. So let us substitute these values into our rational function. So we have limit x approaching 1. We have 1 divided by x minus 1 times x plus 2 minus x divided by x minus 1 times x squared plus x plus 1. On further calculation, we have limit x approaching 1. Now we're going to take the lowest common multiple of the numerator of the denominator of the two rational function. So we have x minus 1 as the common factor, so it will come once. Then we have x plus 2 and x squared plus x plus 1. Now what we're going to do, we are going to divide the denominator x minus 1 times x plus 2 times x squared plus x plus 1 by the denominator of the first rational function. So that will leave us with a remainder of x squared plus x plus 1, which we are going to multiply to the numerator 1. So that will leave us with x squared plus x plus 1 times 1 minus, now we are going to divide the denominator x minus 1 times x plus 2 times x squared plus x plus 1 by the denominator of the second rational function. So that leaves us with a remainder of x plus 2. So we will multiply that x plus 2, the remainder, with the numerator of the second rational function. So that will be x times x plus 2. So on further calculation, we get limit x approaching value 1, we have x squared plus x plus 1 minus x squared minus 2x divided by x minus 1 times x plus 2 times x squared plus x plus 1. So we can cancel out x squared from the numerator. That leaves us with negative x plus 1 divided by x minus 1 times x plus 2 times x squared plus x plus 1. So this is the limiting value of x going to 1. Now what we have is, let me clear the board. So We can rewrite the numerator by taking -1 as the common factor. So we have negative of x minus 1 divided by x minus 1 times x plus 2 times x squared plus x plus 1. Now we're going to do the direct substitution by replacing the value of x with 1. So that gives us 1 minus 1, so that gives us a 0 in the numerator. And we have x minus 1 also present in the denominator, so that will be 0 multiplied to all the other terms, so that will be simply 0 over 0. So this is an indeterminate case. Now it was becoming indeterminate case because x minus 1 is a common factor. It's the common factor in both the numerator and denominator. So what we are going to do, so we're going to cancel out, or we're going to factor out the common term from both the numerator and the denominator, and that is going to leave us with limit x approaching 1. So we have -1 because we have already cancelled out x minus 1 from the numerator and the denominator, and we have x plus 2 times x squared plus x plus 1 in the denominator. Now we're going to replace x by 1, so that gives us -1 divided by 1 plus 2, which is going to be equals to 3 times 1 squared plus 1 plus 1, which is 3. So we have a final value of -1 over 9. So this is going to be the limiting value of our rational function when x approaches 1. So here we have to find the limiting value of the given function when x approaches square root of 2. So let us begin by first doing a direct substitution for the value of x. So we have square root of 2 raised to the power 4 minus 4 divided by square root of 2 whole squared plus 3 times root 2 multiplied to root 2, which is simply root 2 squared minus 8. So we have square root of 2 multiplied to itself 4 times, so that is simply equals to, so we have root 2 times root 2 times root 2 times root 2. So this will be 2, root 2 times root 2 will be 2, so that gives us 4. So we have 4 minus 4 in the numerator divided by square root of 2 whole squared will be 2 plus 3 times 2, which is 6 minus 8. So we have 0 divided by 0. So this is an indeterminate form. So that means we have to factor out x minus root 2 from both the numerator and denominator. So this is the common factor. So let us begin by first factorizing the numerator. So we can rewrite the numerator as x squared whole squared minus 2 raised to the power of 2. So that will give us x squared minus 2 times x squared plus 2. So what we have done is we have used the identity that a squared minus b squared is equals to a minus b times a plus b. Now what we can do, we can rewrite 2 as square root of 2 whole squared, so that we can reapply the identity a squared minus b squared, and that should give us x minus root 2 times x plus root 2 multiplied by x squared plus 2. So let me clean up the board. Now we have to factorize the denominator. But here we see that we have an irrational number root 2 involved in the denominator, which was in the midterm. So we divide this quadratic polynomial by x minus root 2. We're going to do a synthetic division here. So we have x squared plus 3x root 2 minus 8. So what we do, we pull out all the constant coefficients. So the coefficient of x squared is 1, the coefficient of x is 3 root 2, and we have the constant coefficient, which is negative 8. Now what we're going to do, we're going to draw a small box with the number square root of 2. We draw a straight line and then we pull down the value, the first value, which is 1. So we're going to take the value of 1 and multiply it to the square root of 2 and then place the value out here. So that will be 1 times square root of 2 is simply square root of 2. So we place square root of 2 below 3 root 2. Now we're going to add the two values down the column, so that will give us 3 root 2 plus root 2 is going to give us 4 root 2. Similarly, we're going to multiply 4 root 2 with root 2. So we have 4 root 2 times root 2, which is simply equals to 4 times 2, that gives us 8. Now we're going to place 8 directly below negative 8 and we add down the column, so that gives us a 0, which is indicating that the remainder is 0. So we're concerned only with the first two values, so 1 and 4 root 2. So this will represent the coefficient of x, so which is 1 times x, plus the constant term 4 root 2. Meaning, so x squared plus 3 x root 2 minus x can be written as the product of x minus root 2 and this binomial, which is x plus 4 root 2. So now let me clear up the board. So now we're going to replace the numerator and denominator by this factored values. So we have limit x going to root 2, so x raised to the power of 4 minus 4 can be rewritten as, so we have x minus square root of 2 times x plus square root of 2 times x squared plus 2 divided by x minus root 2 times x plus 4 root 2. So we can factor out the common factor x minus root 2 from both the numerator and the denominator, and that leaves us with limit x going to square root of 2. We have x plus root 2 multiplied to root 2 squared, which will x squared plus 2 divided by x plus 4 root 2. Now we're going to substitute the value of x. So we have root 2 plus root 2 multiplied by root 2 squared will be 2. So we have 2 plus 2 divided by root 2 plus 4 root 2. So root 2 plus root 2 will give us 2 root 2 times 2 plus 2, which is 4, divided by 5 root 2. And this root 2 will get cancelled out from both the numerator and the denominator, leaving us with 8 over 5. So this is going to be the limiting value of the given function.